Hello everyone. In this video, I'm going to discuss the concept called collection classes. So this collection classes has been categorized into three fields. So one is with the empty list and empty set and empty map. So these are used to get the immutable empty list or else map or else set. Okay, so whatever we are going to create, so that will be used to get some empty list or else empty map or else empty set. Okay, so here the collection class will be making use of some of the methods. Okay, so by making use of that methods, we can able to provide the collection class in Java. So if, for example, see, in the last video, we have come across with the various types of methods that we are using in Java, no? That means in collections of Java, no? Here, I'm going to use this one called Boolean add all, okay? So which is going to add all the elements to a specific collection. Okay, so here we should have to separate that element with a comma. So this is the example for specifying that method for a collection over here. So I'm going to create a list. Okay, I'm going to give the object name called fruits and I'm going to make use of a new keyword and creating a new array list. And here I'm just specifying the method called add all. So with the representation collections, that means whenever we need to make use of a method, we have to represent like collections dot add all. Okay, and here I'm just separating that each and every element by a comma. Okay, and this is the name of that list. That is the object I have created, not fruits. So that is the name. And here for those collection, I'm just trying to include apples, oranges, and banana into that list. Okay, after adding all this one, I just want to print all the strings which I have included in that array. For that, fruits dot for each system dot dot print array. So if I'm going to represent this way, so it will be displaying the strings whatever we have been tried to include in that array, that is apples, oranges, and banana. So this is how we are making use of a collection method in a collection class. And in this video, we are going to discuss only the examples that are related to this for a list or else for a map or else for a tree like that. So we are going to discuss the various types of examples. And here I'm going to use of a method called void sort. So which will be doing the sorting over here. We can do the sorting in an ascending order or it's in a reverse order. So here, if you observe in this example, I'm going to specify that collections dot sort, okay, and I'm going to take the array called fruits. Okay, so here I just want to specify that system dot out sorted according to the natural order. So natural ordering in the sense it comes in an ascending order only. Okay, that means in an sequential order, alphabet sequential order only. Whereas, and I'm trying to print that one. After that one, again, I'm just applying the collection sort. And here I'm just representing comparator dot reverse order. So what does it mean in the sense? It is going to print the elements in the reverse order. Okay, so here the natural ordering in this is in an alphabetical order, whereas in the reverse order in this is reverse to that alphabetic order. Okay, I'm trying to print those two sorting orders. So for this collection, okay, I'm just passing the elements. After passing the elements, I'm just before reverse order, I'm just trying to print the elements in a natural ordering. After that, I'm trying to print the elements in a reverse ordering by representing comparator dot reverse order. So if I try to run this code, here we will be getting the output like, so firstly I have given with the natural ordering, so sorted according to the natural ordering, and it will be displaying the in a sequential order called A, B, and that is apples, banana, and oranges. Then again it is intended to print the elements in the reverse order. So here the sorted according to the reverse of natural ordering is, it is doing the reverse of this natural ordering, that is oranges, banana, and then apples in this way. Okay, So this is how the sorting method is going to get performed in the collection. Next, so in this collection framework, as I told you that we are going to discuss the various examples that is related to list, arrays, hash, and trees. Okay. So firstly, coming to the list. So list is nothing but an ordered collection. No? That is by default we can say it as a sequential order. So here for that one, as I told you that collections will be responsible. So we are going to take this collection classes or interfaces by making use of the package called utility. No? So here I'm going to represent that utility package, and then I'm going to define the class and then main method, and then now I'm going to create a list. For the list which I have created, I'm trying to add the elements into the list. In hardware, we are going to represent in adding the elements in that particular list. So it is going to display those elements in the sequential order. Okay, so it is going to iterate those elements, that means it is going to read the elements in the list by making use of a for loop over here. Okay, and it is checking whether the next element is present in that list or not. And after finding all those elements, it is going to display the elements in the order which we have specified. So this is nothing but ordered collection. Next one is array list. So we can say this implementation as a resizable array. Okay. So here the declaration will be that is directly we can make use of the class called array list for this program. Okay. So here we'll be representing like saying the representation will be like if we are going to make use of this array list class in this sense, then public class array list. So with the elements, we are trying to insert some elements. Now here E is nothing but the element representation and extends abstractly. Okay, and then again elements implements list. Okay, so that means here we are just trying to declare this array list in collections. That's it. Okay. Otherwise, we can go with this one like so we can just represent star. Okay, and then main class and main method. And here I'm going to define the type of that array as a string, and I'm going to create an array list. So I'm going to add some objects into that array list. That means mango, apple, banana, and grapes. Okay. And after inserting some values into that array, and I'm trying to print that array objects. Okay. So here also the same thing. We will be getting and in the same order. Okay. This is with the array list. Next one is linked list. Okay. So linked list is also the implementation, that means it comes under this list interface only. It comes so under the interface called list. Okay, here, so under this list, linked list representation, so each element that is present in that linked list is called a node. We are calling it as a node. And each node will be containing the two items. One is with the content of the element, and second one is the address of the next node. Okay, so linked list will be consisting of node. That is, each element we are calling in the linked list as a node, and each node contains two items. One is with the content of the element, and second one is the address of the next node. Okay, see if you observe this example. So here I'm going to represent the linked list with the type of string. Okay, I'm trying to add some elements into that list. Okay, so after adding the elements, I'm just trying to add an element to the first position. Okay, so that means already 3 elements are there. After creating this, that means after adding all these elements, I'm just trying to add one more element called Megan, which I want to place before this string. Okay, generally in a list, if you are trying to add some elements to this, it will be coming in a sequential order, right? So without this statement, if I try to print this linked list in this, then I will be getting the output like string, Carl, and then Raj. Okay. Instead of that one, what I'm trying to do in this program in this sense, I just want to add Megan, so in the place of the first position. Okay, and again I'm trying to add this last position, that means in the last position as well. Okay, Rick, And then again in the third position, I'm just trying to add the Glen. That means in between, I'm trying to add some more values in the positions. Okay, so why here I'm specifically mentioning like the positions in the sense. This linked list will be, that means the node will be containing the address of this next node. No, so it will be changing that position. That means it will be changing that address in that particular node. Okay, for example, see here I'm trying to add Glenn in the third position. No? So this Steve usually it will be holding the address of the curve. Okay, but what we are trying to do, so we are trying to insert Glenn in between the Steve and curve. So that Steve address pointer will be referring to the Glen rather than the curve over here. Whereas coming to the Glen address pointer will be referring to the curve over here. Okay, so this is how we are trying to insert some values into the linked list. Why? Because it will be holding the two values called one is with the content and next one is the address. So this is very easy to insert some values into the linked list. Next one is hash set. So this is the set interface, okay, which will be backed by the hash table over here. Okay, so here the same way we are going to create a hash set and we are going to add some elements into the hash set. Okay, so by representing set dot add. Okay, one, that means I'm trying to insert 5 values over here. Okay, and then here I have represented like iterated string I is equal to set dot iterate. Okay, so while I dot hash next, we see while coming across with this hash set, so this is not going to bring the elements in a sequential order. Okay, so whatever that means, however the hash table will be consisting of that elements, it will be just grabbing that elements and it will be displaying that elements based on the condition that has next. If the table is consisting of the next value indices, it is going to bring that element. Otherwise, it will be coming out of the loop over here. Okay, so likewise, how many values that is consisting in that hash table. So it is going to check with the condition whether the table, that is the element that is present in the table has next element or not. If it is having in the sense, it is going to print that one, otherwise it will be coming out of the loop. In that case, so it is going to print all the elements that is present in the hash table. Next one is the tree set. So we can say that the tree set is one of the most important implementations of the circuit set interface. Okay, so why? Because the ordering of the elements will be maintained by this set. So using the natural ordering, or else we can use with the comparator also. Okay, so here also, but the representation is same. Okay, so here also we will be creating a set, that is tree set, by representing the data type, and here we'll be adding the elements. After adding the elements, okay, so here we are doing the iteration, right? So to check whether that set is having the element or not. Okay, so if it is having any repetition in the sense, that means it will be that means it will be representing like only the one representation. So why? Because the memory, that string that is present will be stored in a single memory, right? So that's why it is going to represent the element in a, for it is going to display the output for only one type, which are get duplicated, and rest of the things will be just like that displayed. Okay, in the same way, it is going to check with the condition has next. Okay, and it is going to iterate that. This is what the tree set is meant to. So these are all going to represent the collection classes where we are going to represent with the linked list, or as list, arrays list, hash, and tree set. Thank you.